So this week's homework is going to be dealing with trig identities, and we're still working in 4.3, specifically on page 285. And the homework problems are a little different than anything you've seen before, because we have to use trig identities to find exact values, and then we have to find trig identities to prove how we get from one side to the other side. And so I know you haven't seen this kind of stuff a lot before, so I wanted to, because you're assigned the even number problems, I thought I'd do some of the odd number problems to give you kind of an idea as to how we go about solving these. So in the first few problems, in numbers 37 through 42, it's just asking us to find the exact values using the identities. So the first problem, 37, gives us that sine of 60 degrees equals radical 3 over 2, and that cosine of 60 degrees equals 1/2. And what it asks of us is it wants us to find A, which is the sine of 30 degrees. So we'll start with that. And then it wants B, which is cosine of 30 degrees. And we're supposed to use our trig identities, which you're given in class, to find these. So if we look at problem A, we want to find the sine of 30 degrees. And one of the things that we know is that from our trig identities is that sine of 90 degrees minus theta equals the cosine of theta. And what that's ultimately saying to us is that if I have the sine of 30 degrees, which I do here, the sine of 30 degrees, it's going to equal the cosine of 60 degrees, because if I go 90 minus 30, I get this new theta, right? It becomes the sine of this new theta, which is 60. 90 minus 30 gives us 60. And so when we look at this, we find that sine of 30 equals cosine of 60. Well, we know what the cosine of 60 is. It's given to us. So we can say that the sine of 30 degrees equals 1/2. And that's our A. Now B asks us for the cosine of 30 degrees. And we can kind of use this a similar process, right? Because we also know under that same group of identities that you were given that the cosine of 90 degrees minus theta is going to equal the, I'm sorry, it's like saying the cosine of, is going to equal sine of theta. And that's like saying that the cosine of 30 degrees, right, equals the sine of 60 degrees, right? So if I plug 30 in here, again, I'm left with 60. And so our theta over here becomes 60. And we know what the sine of 60 is because it's given to us in the beginning of the problem. And the sine of 60 is rad 3 over 2. So we can say that the cosine of 30 degrees equals radical 3 over 2. So that's how we handle number 37. Now, in your homework, you're only asked to do A and B, but we can also do C and D if we wanted. We'll do at least C. C asks us for the tangent of 60 degrees. And there's a couple things I can remember. I can remember that tangent is just sine of 60 over cosine of 60, right? Tangent is sine over cosine. So when I do that, I know that the sine of 60 is radical 3 over 2, and that the cosine of 60 is 1/2. I'm given that in the beginning of the problem. Now, that can't be my solution. I can't be left with a fraction over a fraction, but that would be the same as saying radical 3 over 2 times the reciprocal, which is 2 over 1, which gives me 2 rad 3 over 2. And when we cancel that, we're just left with the square root of 3. And so all of these are like little puzzle pieces that we have to keep putting together. And so that covers number 37. Number 41, let's look at another color. Number 41 is asking a similar thing. It's giving us the cotangent of alpha. That's what that symbol is. It's just alpha. It doesn't really matter what it means. It's just saying some angle, right? In this case, we're calling that angle alpha. And we're saying that it is equal to 3. And we want to find A, which is the tangent of alpha. We want to find B, the cosecant of alpha. I'm going to move that over a little bit and see if I can use up a little bit less space. Right. So I'm going to move this over here just so I have a little bit more room. B is the cosecant of alpha. And the only piece of information that I'm given here is that the cotangent of alpha equals 3. But what we know from our identities is that tangent equals 1 over the cotangent. So, and what we know that to be is 3. We know that cotangent of theta is 3. So we're saying that tangent of theta equals 1 over 3. Now that's all I need to know from that right there, right? Is that tangent of theta is 1 over 3. So we can move on over to this part here where it's asking us what the cosecant of theta is. And so what I want to do is I want to look at my trig identities that involve cotangent and cosecant, that have both of those in the same expression. And for us, the one that works would be one of our Pythagorean identities that says that 1 plus cotangent squared of theta equals cosecant squared, of alpha. We're using alpha, right? And what we have a cosecant, right? And now we need to find what that cosecant of theta is. Well, I know a couple of things. I know right now that cotangent of theta equals 3. So this is like saying 1 plus 3 squared, right? Because we know that cotangent of theta equals 3, and this is cotangent of theta squared, equals cosecant squared of theta. I keep saying theta, but our variable is actually alpha. So 1 plus 3 squared, that's saying 1 plus 9. Well, that's just 10 equals cosecant squared alpha. So when I go to solve this, I'm left with one other piece to do. I've got to take the square root of both sides. And when I do that, I am going to be left with the square root of 10 equals cosecant of alpha. We can't break down that square root of 10. I do not want to see a decimal answer when you guys do these. When you're showing your work, I don't want the calculator to do the math. Cosecant of alpha equals the square root of 10 is a sufficient answer. Please do not give me the square root of 10 in decimal form. So that's our A and B portion of 41. Let's look at number 43. Now, number 43 is asking us for, we're moving on. We're saying we have to use trig identities to transform the left side of the equation into the right side of the equation. So we're basically showing how we can prove this. And we're left with tangent theta times cotangent theta equals 1. Well, what we need to do is find how we can break those up. What do I know about tangent of theta? I know that tangent of theta equals sine of theta over cosine of theta. And I know that cotangent of theta is the opposite. It equals cosine of theta over sine of theta. And we're saying that that all equals 1. Well, does it? If I look at this, that's like saying sine theta, cosine, sine theta, cosine theta over cosine theta, sine theta. And that indeed is the same thing over itself because multiplication order doesn't matter. Right? And so we are proving that that equals 1. And that's all we're showing. We're showing how we can get this to equal this. And the reason it works is because tangent is just sine of theta over cosine of theta. And cotangent is just cosine theta over sine theta, which gives us the same thing on the top and bottom. And when we have that, it always equals 1, right? If I had 2 over 2, that would equal 1. If I had 2 times 3 over 3 times 2, that gives me 6 over 6, which still equals 1. That's how that works in number 43, right? They're the same thing. Order doesn't matter when we're multiplying. So even though we have sine theta times cosine theta here and cosine theta times sine theta here, they're exactly the same value. Let's look at number 45. I'm looking at number 45. 45 gives us tangent of alpha times cosine alpha equals sine alpha. And we need to prove that. We need to show how we get from here over to here. So what do we know about tangent? We showed up above that tangent is sine of theta over cosine of theta, or sine of alpha in this case over cosine of alpha. And we're saying that we're multiplying that times cosine alpha. Well, if we look at this, these two, when we multiply them together, cancel. right? They just become cosine of theta, cosine of alpha over cosine of alpha. But we're still left with this sine of alpha. And that's how we're showing it going from one to the other, right? We show that we can do this because tangent of alpha is sine of alpha over cosine of alpha. So let's look at number 47. And I think this is the last one that I'm going to do for you. Well, if we look at 47, 47 says that we have 1 plus sine of theta times 1 minus sine of theta equals cosine squared theta. And this is a little bit tougher, but we can see how this works. So when I look at this, I'm going to take this first part. I'm going to go, okay, well, we've got 1 plus sine of theta times 1 minus sine of theta. Now I look at this and I see it different as squares, but you might not see that right off the bat. So what we're going to do is we are going to distribute each piece, right? So I've got 1 times 1, and that's going to give me 1. And then here I've got 1 times negative sine of theta, so that's going to give me minus sine theta. So we've done everything we can with that 1, so now we're going to multiply this sine theta times each piece. So we've got sine theta times 1, well, that's plus sine of theta. And then we have sine theta times negative sine theta, and that's minus sine squared theta. And if we look at this beginning piece right here, we could go, okay, well, these just cancel out. Minus sine of theta plus sine of theta, that's just a big old 0, right? So if we're looking at that, we can just cross those out. And we're left with 1 minus sine squared theta. And if we remember that Pythagorean identity, we had a Pythagorean identity. We had one specifically that said sine squared theta plus cosine squared theta equals 1, right? Well, let's look at this. If we just subtract sine squared theta from both sides, it leaves us with cosine squared theta equals 1 minus sine squared theta, right? So 1 minus sine squared theta equals cosine squared theta. And that was what we were trying to prove, right? So when we multiply it through, it just equals our Pythagorean identity, and we were able to prove it. So that's just a few sample problems. If you have any trouble with any of the others, please let me know. I'm happy to jump into a meet or something and help you break those down. But that was just a little something I wanted to offer when doing your homework so that you had something to go on. So.